I want to find that one emoji with the upside down face. Unfortunately, I'm not very good at typing and ended up misspelling upside. Not to worry, this is a fuzzy search. With the right emoji selected, I can copy it to my clipboard and get back to what I was doing. Want to learn how to build front-end only search tools like this? Stick around. My name is Christian, and this is Code and Stuff. To get started, let's run npx create React app and then the name of our project, in this case, Emoji Finder. With the project initialized, let's start installing some packages. First, I'm going to cd into the Emoji Finder folder. Now, I'm going to need a list of every emoji along with their names. With a little searching, I found that the Unicode emoji JSON package gave me exactly what I'm looking for. Every emoji along with their associated name. Back in my terminal, npm install save Unicode emoji JSON. Because I'm using create React app, I should just be able to run npm start. Over in my browser, we can see the default create React app page. I actually don't want any of this content. So to reset it, I'm going to delete the boilerplate that was generated by create React app. In source, that is app.css, index.css, logo.svg, and all of the references to those files. And now we're to a roughly blank screen. So let's get a list of some emoji on the screen. To do that, I'm going to import the emoji from Unicode emoji JSON. Now, this is a JSON package, so it doesn't include an index.js file, and I have to go /data-by-emoji.json. Let's map through this object. The structure of the object is the emoji itself, and then an object that contains a name and some other attributes. All that I care about for this project is the name. We'll go const all emoji equals object.entries. Object.entries takes an object and creates an iterator that gives you the key and value pairs. We'll go emoji.map. And in here, we will have the emoji literal and the properties from that JSON file. And we're going to use that to create new objects that have emoji as emoji literal and a name that is properties.name. All right, now I'm going to delete even more of this app. Really all I need is a div as a main container, and then I'm going to use an unordered list. And within this unordered list, I'm going to go all emoji.map. We'll grab the emoji and the name and put in a list item with that name in it, a key of emoji so that React knows how to keep track of it, and we'll put the emoji in the content too. Let's put some parentheses around the name. And now, over in my browser, I can see the grinning face, I can see upside down face, all of these familiar emoji. In fact, the list is quite long, so it's a good thing we're making an app to filter through them and find the one we're looking for. To do that, I'm going to wire up a basic search. Later on, we'll reach for some more advanced techniques. To make this work, I'm going to import useState from React. This is a hook that will let us keep track of what is typed into the text box. Const filter value, set filter value equals useState, and we're going to give it a default of an empty string. Then in here, just above our list, let's add an input. Its value will be filter value, and whenever we change it, we're going to receive an event, and then we're going to set the filter value to the event target, that's the element, dot value. So whatever was typed into the box is what we will update our state to be. Now if I save this and type, nothing happens, and that's because we are currently using all emoji instead of doing filtering. So now we can add filtering. Const filtered emoji is all emoji, but we want to filter them. And specifically, we want to grab their name and then find out if their name includes our filter value. Now, if we just change all emoji to filtered emoji, and then go over to our browser, we should be able to start filtering. Let's look for a winking face. By typing in wink, we've gone through the entire list, found the items that contain those characters, and are only returning those ones. When running a filter, it can be helpful to highlight which area of the text matched your search. For example, if I type in MIL, I know that MIL corresponded to the smiling eyes or to the MIL in family. But we should highlight these search results. I prepared a gist on GitHub that does this formatting. So I'm going to grab that and drop it into our code base. The way that this works is it takes a list of indexes and the string value and then turns it into a span with bold segments in the middle. Now it does reference React directly, so I have to make sure to import that. So we're going to take our filtered emoji and run another map function. And we're going to take our result and we're going to create a copy of all of the fields on our result. And we're going to add a display name property. And this will be the result of format match. For indices, we're going to need to come back to that. And then we're going to have our value is going to be result.name. Now to find the indices, we need to find where in the text our match happened. So we'll declare match start to equal result.name.index of filter value. So our indices will be from match start to match start plus the length of our filter value. So now all that we need to do is grab the display name and show it here. We'll use name as a fallback in case something goes wrong with display name. Now over in my browser, I can see the highlighted MIL in all of these search results. Now we've already got something pretty fast that's working pretty well, but we can do better. One example is that if I make a typo, I don't get any results. If I were to type in cactus, I'll see the result cactus. But if I were to make a typo like catcus, I don't get any results. There's also no sorting by relevance. All of my results are in the order that they came in from the JSON file. To solve these problems, I'm going to reach for a library called Fuse.js. This library is designed to support client-side fuzzy filtering with match highlighting and relevance ordering, which is exactly what we're looking for. So I'm going to install it in my project, npm install Fuse.js. So the way this library works is we have to create an instance of the Fuse class, and then we run this search method and we get a result. And that result is an array of objects which have a key called item, whose value is the original item that was entered into the search index. I'm going to just comment out the existing emoji filtering and start out from scratch on Fuse.js. So I'm going to import Fuse from Fuse.js. Then in our render, let's go const Fuse equals new Fuse. This takes in the list, which in this case is all emoji, and then a configuration object. This object tells the library, among other things, which field you want to search. So we'll go keys is equal to name. Then we can grab the results. So we'll go filtered emoji equals fuse.search filter value. Now, like I said before, this returns an array that has objects with a key item where our results are. So we're going to do some mapping. We'll map our result to result.item. Now, if I go over to our app and type in catcus, I get cactus. And I also get relevance ordering, but I don't have any highlights. Much like in our first example, it'll take some effort to highlight search results. Before we do that, let's refactor this emoji search into its own React hook. By refactoring it out, we can have more isolation of our search state, and we won't unnecessarily run our search when the query didn't change. So I'm going to create a new file and call it use emoji search.js. I'm going to grab all of the app so that I have all my imports right and paste it into here. And then I'll write export function use emoji search. This function will take in a filter, which will default to an empty string. And then within there, it will create a fuse instance. It will do our filtering. And finally, we will return a result of filtered emoji. Now I can get rid of all of this other old stuff that I'm not using anymore. Save this and then go import it over in app.js. So I'll import it and then start relying on it down here. Const result reassigned to filtered emoji equals use emoji search with a filter value of filter value. Now I can get rid of these, get rid of our old code, get rid of format match and all emoji. All of these imports go away because we have encapsulated our search into our use emoji search hook. Now there is one error from my copying and pasting. I need to make this refer to filter instead of filter value. And now if I go over to my browser and type in something like giraffe, I can see my results. To make this more performant, I'm going to import a hook called useMemo. This hook memorizes the result of a function and only re-executes it whenever the dependencies change. In this case, we're going to go useMemo and then give a function that returns the fuse instance and set its dependencies array to an empty array, meaning only do this once. All right, now that everything is optimized, let's enable the include matches option. This Vue.js option will return the indexes of any search hits. So I'll enable include matches. And then down in the map, I'm going to grab all of the properties of the result item and then also set a property called display name to the result of format match. That's going to take in result.matches 0. Result.matches already has a structure that contains indices and value. Now, if I go over to the app, I can type in cat and see cat being highlighted. I could also see the AT from rat being highlighted, explaining more about why that was a fuzzy search result. So this is still a huge number of results, and a lot of these aren't very relevant. Let's limit our result set to the first 100 and then return the total number of hits in our hook response. To do this, I'll set a limit with a default value of 100. So when I'm constructing the result, I'll run a slice of 0 to limit, and then I'll also return a count value of filtered emoji.length. Now we're only returning up to 100 results, and whoever's calling the hook can also figure out what was the total number of results, even though we're only showing a little bit of them. It's also frustrating that when the filter value is empty, we don't see any emoji. To address that, I'm going to write if filter is equal to an empty string, then let's return a result with all emoji sliced down to our limit. And for count, we'll return all emoji.length. Over in the app, there's 100 results whenever we don't have any filter value. There's also still a problem of really irrelevant results. I don't think that I was looking for canned food when I typed in cat. Vue.js does have an option for this. It's called threshold. And for my experimentation, a value of 0.35 works for me. You'll want to play around with this value to figure out what is most relevant in your application. For one last thing, for fun, I want to style this to look like Microsoft Windows 98. The thought of modern emoji showing up in a 90s operating system felt just silly enough to attempt. Luckily, there's an open source project called 98.css that makes this style really easy to emulate. I'm not going to bore you with the exact details of this refactor, so let's start a time lapse. All right, welcome back. So here's the finished product. An emoji finder that can tolerate typos, highlight matches, and when you select one and click on its preview, copies it to your clipboard so that you can paste it wherever you need it. As always, the code for this project can be found on GitHub with a link in the description. In summary, we were able to get client-side filtering set up. More than just exact substring matching, we can use a fuzzy search library to provide a better experience. Many teams will reach for a backend search service like Elasticsearch or Algolia. These are great options when datasets are huge or when you're in a bigger team, but they can be overkill for some simple use cases like a small documentation site. When prototyping as a front-end developer, know that there may be a simpler option. This has been Code and Stuff. Thanks for watching.